Thank you. Thank you so much for being here. I promise not to hallucinate much. I've been trained in fine-tuned to speak the truth as much as possible, right? But you never know. Yeah, and it's going to be natural language conversation as well. So not a long time ago, ML and data science was the hottest topic, right? And AI just meant a superset of all of this. Today, AI just means GenAI by default, unless you specify what we mean by that. I think somewhere from the time ChatGPT caught our fancy to now enterprises really thinking about where can we make use of GenAI, I think we have come a long way. What we are seeing is the enterprises becoming a little more stable about where they want to use it. The use cases and applications are becoming a little clearer. And it's not either a doomsday scenario of GenAI trying to replace everything, including all the people out here, not a gloomy scenario of does GenAI really mean anything for us or not, right? So we are seeming to settle somewhere in between, finding the right use cases and applications. And that's what we call as the era of enterprise AI, where enterprises, businesses are becoming more clear about where to deploy GenAI and so on. But they also have different type of concerns. When enterprise businesses deploy GenAI, they think about reliability, trust, the quality of responses. For example, if ChatGPT gives a wrong answer to a consumer, to me as a user, it may not harm me much. You know, the responsibility is on me. But if the same answer comes from a company about, say, medical insurance policy of the company to a customer, or a travel itinerary of a traveler, the consequences can be a lot more heavy, right? So that's why enterprises have to be a lot more conscious about implementing GenAI. So we'll talk about some of those concerns and where Snowflake can really help with that, right? So some data points before that. You can clearly see that GenAI is getting adopted at a breakneck speed. It took just 2 years to reach the same levels where traditional ML reached in almost 10 years. About 65% of enterprises are adopting GenAI in some form and shape, right, based on the research we got conducted. Still, traditional ML is not dead. Traditional ML is still growing, a lot more use cases, very specific use cases, and which has to be more precise, right? So those are still continuing, but GenAI has been growing at a much, much rapid pace. The problem is this. While the adoption has been great, there is a lot of pressure from the board and from the top to adopt GenAI in whatever form and fashion, right? The question is not, should we adopt GenAI? The question is, what have we done to adopt it? So there is a lot of pressure from the top. The problem is moving these from pilots and experimentation stage to productionization. How do we move these huge number of experiments which are happening in different pockets of the enterprise and moving them to high quality, high fidelity production use cases? And what really deters enterprises is few things, like the quality of responses we talked about, the hallucinations, the cost of deploying these systems. While the cost of tokens seem to come down, you know, the tokens cost keep going down, but building these systems require integrating multiple components together, you know, getting the data in place, building the applications on top, and so on, and the skill sets of the people, right? So there is still a lot of complexity and effort and cost involved in building this at production scale. We can quickly whip up a code asking questions from ChatGPT, but really making it production grade takes time, effort, and cost. So these are some of the issues which we see in enterprise AI today, right? So when Snowflake started to adopt these and built it into the platform, Snowflake is known for the data platform. And how many of you are familiar with Snowflake here in the audience? Oh, quite a bit. Oh, wow. Oh, I'm in great company. Thank you so much. So home to almost 10,000 customers' data. When we started building this about 2 years ago, integrating all of this, we tried to extend the same principles which we applied to the data to the GenAI as well. For example, wanted to make it as easy as possible. Any technology which sees mass adoption has to be very easy to use. Otherwise, it remains a very niche technology in the hands of rocket scientists, people we aspire to become so that we become indispensable, right? But it doesn't see mass adoption that way. So we have to make it really, really easy so that anybody in the organization can make use of that. And that's what we did with data, made data really, really very simple to use. So what we did is make it fully managed. You don't have to worry about managing underlying models, infrastructure, and the governance. Make it really easy. The second part is the efficiency. Whatever models you bring for production has to be really state-of-the-art, give you the best bang for the buck, so lowest cost and the best results there, right? So provide a home for state-of-the-art models, providing the best efficiency, lowest inferencing cost, so on and so forth. The third one being trusted, and this is the biggest concern for enterprises, right? Like I mentioned, the responses have to be high quality, highly accurate, and so on. At the same time, you need to make sure that these models are explainable, there is good amount of observability built in, and this is grounded in the truth of your enterprise data. It's okay to train a model on internet data and then ask questions to it, but for enterprises, it has to be grounded in real enterprise data, which is the truth, the single source of truth, right? And then when we build the whole platform or the capabilities around GenAI, firstly, you have to have a very strong data strategy, right? As you could see, the best way to address the quality of responses is have the right level of data. So collect data from all the different enterprises sources, be it my Salesforce, HubSpot, Jira, or whatnot. Get all of this data in a single place in what you call data lake, data warehouse, data lakehouse, data mesh, or whatever, and provide all the quality metrics around that. Make sure this data is really high quality, high fidelity. So that's what we do with the data foundation. So a solid data strategy is a foundation for a solid enterprise AI strategy. So that's the first thing you address. Once you have the data in place, it's really taken care of. You can quickly build AI applications and use cases on top of that. And how do we make it really simple to accelerate the AI projects? But the work is not done here, because AI is rarely consumed as models, right? AI is most commonly used in form of an application. It's an external user or a consumer which talks to my application. There are businesses who have to interact and iterate on that application, do a prototyping, deploy in production, and so on. How do we make this mass-scale consumption and distribution in place? So that's the third layer of application. So all the way from setting up a right foundation to productionizing via application use case, there is a complete spectrum of the GenAI lifecycle, right? And what we feel is, as the natural place for all the data, this platform should also be the natural place to implement GenAI from development all the way to productionization via applications, right? So a few components of the platform. I think some of you who are already familiar might have seen the architecture, but I'll just quickly iterate on it. So firstly, bring all data in one place. So if you look at the innermost, sorry, I've been blocking the view all this while, is it? If you look at the innermost circle, the interoperable storage layer, that's where you bring all the data in. First-party data, second-party data, third-party data as well. Snowflake makes it really easy to get data from external sources. This could be your ecosystem partners. This could be third-party marketplace data providers. So you get all of the data in one place within the interoperable storage. Now, this could be Snowflake's proprietary format, which is very optimized, or this could be open table formats like Apache Iceberg. There's a huge community evolution towards Apache Iceberg, and you can bring data in that format. The second thing being the built-in governance. So there are things to manage data and models, things like Horizon, model lineage, data lineage, role-based access control. So whatever governance we are extending to the data, we are extending the same governance to the models as well. Once that is done, now going anti-clockwise, the third thing being bring AI to your data. Now, more often than not, we are taking data to the AI model. Yeah? So when we ask a question to OpenAI or ChatGPT, the data goes there, and then we get the response back. Now, many enterprises are not OK with that. They would like to keep the data, the models, the prompts, the responses within the security perimeter which they have defined, right? So we bring AI to the data rather than taking data to the AI. That also makes the process more efficient, less egress, less network traffic, so on and so forth. And finally, once we have productionized the application, once we productionize the AI model, develop an application around it, use components like Streamlit, for example. So anybody familiar with Streamlit here in the audience? Oh, wow, great. It has been an open source framework available inside Snowflake as well, or you can continue to use it outside Snowflake. Build applications, or you can also have containers where you deploy these applications. and then productionize them. Now, one step further, once this application has been built, you can also monetize this via the marketplace. So if we are a product development company and we want to monetize this application, we can offer it on the Snowflake marketplace. Actually, met a couple of folks outside the room, and they are doing exactly that. They built applications on data, and they are now productionizing it and monetizing it via Snowflake marketplace. All right? And as a consumer, you can consume those applications immediately alongside your data in the same platform. When we look at the platform components, I talked about few of them already. I talked about the data and model governance piece, role-based controls. So the thing about generative AI is this, right? How do I make sure that the model is providing response only to authorized people? Because when it is about data platform, we can provide access controls. But when it comes to LLM models, the model does not know who is authorized to ask what kind of questions, right? So how do we stitch the access control layer, which is on data, and extend that to the models as well? Yeah? So that's what we ensure by being that single platform. All the infrastructure which is required to bring these models in place, be it GPUs, CPUs, containers, providing that as part of the platform. Then making it simpler for people to either bring open source LLM models, for example, Llama 2, Llama 3, or providing easy to consume LLM models out of the box. So what Cortex AI does is makes all of these LLM models available as a serverless function. So all I need to do is go and invoke something like sentiment analysis. And in the backend, Snowflake is running an LLM model, doing the exact thing for me, without me having to bother about, hey, which model should I use? Which will be the most efficient one? So Snowflake takes care of all of that. All I do is go and invoke that function. So that's what Cortex AI does, provides serverless LLM functions available to you with best of state-of-the-art models behind the scenes. In case you want to build traditional ML use cases, there is a component to do ML development, all the way from model building, fine-tuning, and then deploying it in production. And then for the developer, if I want to use a no-code, low-code tool bench, we have Studio. There are notebooks. We just talked about Streamlit. And basically all of these to let developers build the applications of their choice. So we talked about three things, right? Easy, efficient, and trusted. That's what enterprises are most concerned about. To take the easy piece, what we do to make it easy is, firstly, you have the foundation models, right? This could be from NVIDIA. This could be from Mixtral Large, Mistral, Gamma models, Reka, and all of these. So we make these models available as part of the Snowflake platform itself. You can also deploy these from, say, Hugging Face, bring these models into the Snowflake platform through containers, or as a readily available, ready-to-consume models via Cortex functions. So models is the first layer on top of Snowflake platform. So really making it easy to consume end-to-end. Second thing I talked about was efficiency. How do we make it really efficient? So we have state-of-the-art models. Like I talked about Reka, Llama from Meta, Gamma from Google, and so on. So there are a bunch of models which are available as what we call model garden in Cortex. So you can choose which model I want to call for which particular function. You can also see their performance side by side. So there is a playground. So let's say you build a search using Mixtral versus something else, and then you compare the responses of those chatbots side by side. The playground actually lets you do that. So bring those best of the state-of-the-art models. And then Snowflake's AI research team has its own LLM models called Arctic. So there is Arctic LLM model, which is good for instruction following, SQL generation, and so on. There is Arctic Embed, which is very good for search-type use cases. So what we are using in Cortex Search is basically Arctic Embed, one of the best models when it comes to retrieval performance on top of unstructured data. So the embeddings go into Snowflake tables, and then using those embeddings, build an index to provide responses back. And then Arctic TILT is what powers document AI. So TILT means text, image, layout, and table. So any form of unstructured document, scanning images, table layouts, infographics, and so on, populate that in tables to really work on top of their data. And finally, trusted. So the data and model governance through Horizon, registering these custom models as a model registry So you can only invoke if you have the right level of permissions and authorizations, right? So not everybody can invoke those models. And finally, implementing guardrails. So if I ask any harmful questions, for example, how to build guns, the guard should actually stop me, or rather not provide those responses that, hey, this is a harmful content. I'm not supposed to display answers to this particular thing. The one thing enterprises are most cautious about is how do I not let my data be used by the LLM providers for training, right? Because ultimately, these models get trained on the enterprise data. So there is a trust and safety commitment that the data never is used for training our models. If you fine-tune the models on your data, they remain particular to you. They are not used for the broader customer base, right? So your data does not leave your Snowflake account. The prompts do not leave that. And then we do not use them for training our models. Few examples of customers making use of GenAI applications on Snowflake. For example, Bayer, they have their finance teams and sales teams asking questions of their enterprise data via chatbot using Cortex Analyst, right? So basically making them more productive rather than using dashboards and reports. Zoom is basically using this for their customer success teams. So they get data from Salesforce and HubSpot, and then as they're interfacing with their customers, they get this data, get the answers before they talk to their customers. Sigma trying to find the propensity to buy, which customers are more likely to buy by scrapping the web indicators, combining them with their internal data, and then enriching the leads, scoring the leads, and prioritizing them via this use case. So these are the three broad categories of use cases we see: automated BI, conversational assistants, and then text processing and summarizations, right? These are the most common use cases we are seeing. Of course, content generation is also there, but when it comes to enterprise data, how do I make use of it and put this into the hands of more people? Typically, it is into one of these categories, right? So giving my analyst more power through natural language, build assistants for my frontline people, and then a huge amount of text data, the documents, the images we are getting, how do we process text on that? Of course, we are becoming more multimodal now, so instead of just text processing, people are also interested in images, videos, audios, and so on. So what we also do is provide best of these models via marketplace. For example, there is a company called Landing.ai, founded by the renowned professor Andrew Yang. What they do is they are very good in computer vision. They'll take very less amount of data to train their model, and Landing.ai is available on Snowflake Marketplace. So if you have use cases around videos, images, and for example, quality inspection, or finding something in the food item through the images, you can use Landing AI, which is available on Snowflake Marketplace. So there are more computer vision and audio type of use cases also coming in now, getting more mature there. On the other side, if you are building traditional ML, predictive ML or discriminative ML, there are enough use cases around that. For example, financial planning, market basket analysis, CRM, so on and so forth. So like I said, traditional ML is not dead. There are a huge number of use cases around traditional ML as well. And again, all the way from feature engineering for these traditional ML models to training the model and then deploying the model. You can do that end-to-end ML lifecycle and ML ops process inside Snowflake. Bunch of use cases around traditional ML as well. I talked about few of them: sales, marketing, security risk, forecasting, pricing and ads, and supply chain and manufacturing, right? So these are some of the traditional ML use cases we see out there. Finally, I think skilling and enablement is one of the big areas for generative AI, because no matter how much we do, there is a huge demand for this. So there is a number of resources available on generative AI from Snowflake side. You can actually read up about these. There are quick start guides, so you can start following. I think most of the topics I touched upon: Cortex Search, Cortex Analysis, Document AI. You can start following these quick starts and building on your own to learn more about it. Right, that was pretty much it from my side. Implementing enterprise AI, and how does Snowflake help you over there?